Hey guys, for the next lesson in 6.1, we're going to be talking about more exponent properties, specifically with powers of products property for exponents. So I just want to introduce this idea about the radical, but we'll go into that more when we get to more properties. Just understand, remember, 4 squared just simply means 4 times 4, 16. 6 squared means 6 times 6, which is 36, etc. Whereas a square root means what times itself equals 81. Well, that's 9 times 9. So the answer is just 9. What times itself equals 16. 4 times 4 equals 16. So the answer is just 4. What times itself equals 4? 2. What times itself equals 100? 10, because 10 times 10 is 100. And then here's a big chart for you guys to reference when we're talking about simplifying radicals. But specifically for just the 1/4, 6.1 and 1/4 section for the homework on this is what you need to know. So when you multiply two powers with the same base, you add the exponents. So a to the n times a to the m just means I take n plus m, and that becomes my new exponent. For example, 5 times 3, or 5 to the third times 5 to the fifth, really just means 5 to the third is 5 times 5 times 5. And 5 to the fifth is just 5 times 5 times 5 times 5 times 5. Well, how many 5s are being multiplied? 1, 2, 3, 4, 5, 6, 7, 8. 8 5s in total are being multiplied, so this is really 5 to the 8th. Well, how do we get 5 to the 8th? 3 plus 5. So when we look at these, again, this is only true if they have the same base. If this were 5 to the third times 4 to the fifth, not the same base, I can just add the exponents. I can't simplify that any further, in fact. So for these, 4 to the third times 4 to the 8th, that means 4 times 4 times 4 times 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now all of that together, I have how many 4s being multiplied? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because 3 plus 8 is 11. So this is just 4 to the 11th power. That's all that is. And you can do the same thing with negative exponents. There's negative 4 6s being multiplied here, and there's 9 here. Negative 4 plus 9 is just 6 to the 5th. Okay. Same thing here. How many 7s are being multiplied? Well, 6 here, 0 here, and 7 here. A total of 6 plus 0 plus 7 is just 7 to the 13th power. Here, how many x's are being multiplied? Well, there's 4 x's being multiplied here. There's 2 x's being multiplied here. There are a total of 6 x's being multiplied. There's 3 y's here and 1 y here. It doesn't say to the 0. There's 1 there. So remember, you always have to remember the imaginary 1. So that means there's a total of 4 y's being multiplied there. Now on these, I got to take 2 times 3. So I take 2 times 3, I get 6. How many n's are being multiplied? 3 here, 4 here, for a total of 7. How many m's are being multiplied? 2 here, 4 here, for a total of 6. And here, I take 3 times 1, so that's just 3. I have 0 x's being multiplied here, and I have 4 x's being multiplied here, for a total of just 4 x's. I have 1 y here and 1 y here, total of 2 y's being multiplied there. Okay, so that's the product of powers property. Now the last one you need to do your homework is the quotient of powers property. I want you to think of this as, remember, 2 to the 6th power means 2 times 2 times 2 times 2 times 2 times 2. On the bottom here, it's 2 times 2 times 2 times 2. How many 2's are up top? 6. How many 2's are on the bottom? 4. Well, what is 2 divided by 2? Remember, anything divided by itself is just 1. So really, and then when you multiply anything by 1, it's just itself, so it just kind of cancels. So 2 divided by 2, gone, gone. I'm left with 2 2's, and they're in the numerator. So that equals 2 squared over 1, which is just 2 squared, which is really just 4. So that whole thing equals 4. Okay, same thing here. So I have 9 4's. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have 5 on the bottom. 2, 3, 4, 5. These cancel. I'm left with 4 on top. So that is 4 to the 4th. 4 to the 4th, 4 times 4 is 16. 16 times 4 is 64 times 4. Oop, gotta check that. Yeah, 256. Thought that, but I almost said 216. So, all right. Now, let's look at these. So really, all we did, how do we end up with that? Just like we did here, we subtracted. Same thing here. 9 minus 5 is 4 to the 4th. Okay, so these 7 times 7 times 7 times 7 times 7 times 7 times 7 all over that. So 1, 2, 3 cancel. I'm left with 7 to the 4th power. So that is 200401. Okay, on this, 12 to the 10th. So I don't need to write out 12 or 10 12s anymore. I don't need to write out 12 this many times. I just know that there's going to be 10 of them up top, and there's 5 on the bottom, which means I have a total of 5 left. 12 to the 5th. Is 248,832,000. Okay. Now here, I have 4 on top, 4 on bottom. So when I do this, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. When these cancel, notice I have 4 on the bottom. So this is 1 over 8 to the 4th. 1 over 8 to the 4th is 4,096. So we get that. Now here with variables, I have 5 x's on top and I have 3 on the bottom. That means I have a total, when I write this all out, I have 1, 2, 3, 4, 5. 1, 2, 3. And y's I have 1, 2, 3, 4, 5, 6, 7, just 1. So when these cancel, I'm left with 2x's and 1, 2, 3, 4, 5, 6 y's. Because 5 minus 3 is 2. And 7 minus 1 is 6. Now here, notice there's a 3 in the bottom. Well, that doesn't cancel with anything, so just leave that 3 on the bottom. I have 1n up top, so leave that up top. I have 2 m's on top and 4 on the bottom. So I have m times m, and I have 1, 2, 3, 4. Those cancel, so I'm left with just 2 m's on the bottom. So I'm done there. This one, what does 8 over 4 simplify to? If I just asked you to reduce 8 over 4, you would say, oh, that's 2 over 1, or just 2. Or let's say it was, you know, let's say 6, 18, 3/9, which is 1/3. Always reduce as much as possible. Don't just settle for the first one. Reduce as much as possible. So in this case, 8 over 4 is the same thing as 2 over 1, or just 2 on top. I have 0 x's up top, but I have 1 on the bottom, so that means I have 1 left on the bottom. 5 y's and 3 y's means I have 2 y's left up top. There's my answer. So let me get you started on your homework. I'll do the first couple, and then you'll do the rest. So here's the worksheet that's on Canvas. This goes back to those first few examples. There's 3 8s here, there's 7 8s there. Total of 11 when you add 7 and 3. And you don't need to figure out what 8 to the 11th power is. And yes, on these, there's not really a whole lot of work to show. Do the same thing for 2 and 3 and even 4. Remember, that's no 6's there, that's 0 6's, and then you just add -5 and 11, just like you did with the positive numbers. Now these, take 4 times 9. Now those are not exponents, you're not adding them, those are numbers. If I just said 4 and 9, you would say, oh, I'm multiplying those, so it's 9 times 4, which is 36. I don't add them because they're not exponents. I have 3 g's being multiplied here, and I have 5 g's multiplied here. I have a total of 8 g's being multiplied. So I'm done. Do the same thing here, except for here's with more. So I get 7 and 6. So remember, I don't add those, I multiply them. So that's 42. I have -3 z's, and I have positive 8 z's there, for a total of 5 z's. 4 h's and 5 h's, total of 9 h's. Do the same thing for 7 and 8. And honestly, yeah, the rest of those as well. And lastly, down here, I have 10 10s up top, and I have 6 on the bottom. That means I have a total of 4 left up top, because 10 minus 6 is 4. So this is just 10 to the 4th. Here, I have 5 6's on the top and 9 on the bottom, which means I'm going to have 4 left over on the bottom. So that becomes just 1 over 6 to the 4th power. Okay? Do the same thing for those. And then just remember, on ones like this, if it's 8 over 4, that reduces to 2. Or 10 over 6, that reduces to 5 over 3, etc. And do the same stuff. Actually, I'll do one with the variables. So 5 x's up top, 3 on the bottom. It means there's going to be a total of 2 x's on top. 9 y's over 3 y's means there's going to be a total of 6 on the top. Now let's say these are reversed. If it looked like this versus where this was 9 and this was 3, then that would change this. So if there's 3 on the top and 9 on the bottom, that means there'd be 6 on the bottom. That's all that changes there. All right, well, I hope that helps. That should get you in pretty good shape to do this worksheet.